A system of inequalities in two variables means that we have two or more inequalities that need to be solved at the same time. In order to do that, we'll graph each one of them individually and then find out where their solution regions overlap. When graphing an inequality in two variables, if we have the strictly greater than or strictly less than symbol, we're going to graph that equation with a dotted line. But if we have greater than or equal to or less than or equal to, we'll use a solid line when graphing the inequality. Let's start by looking at y is greater than x squared minus 7. And in order to find the solution region, we'll treat it as if it's an equation and graph the equation. X squared minus 7 is a parabola that's opening up and has been shifted down 7 units. So that looks something like this. But because the inequality was strictly greater than, we need to use a dotted line to graph this. Now we'll choose a test point to determine whether the region that is inside the parabola is the solution set, or perhaps the region that is outside the parabola. And since this parabola does not pass through the origin and the origin point is clearly inside the parabola, we'll use this origin point as our test point, and we plug that back into the original inequality to see whether or not that region is going to be part of the solution. So we plug in 0 for y, and then we plug in 0 for x, and now we need to say whether or not 0 is greater than -7, and it is. So 0, 0 does work, and therefore the region that includes this 0, 0 test point is part of the solution region for the first inequality. But in order to determine the solution to the system, we must also now consider the solution to the second inequality and find where these two solution regions overlap. So now we're looking at y is less than or equal to x minus 4, and we're going to graph this as if it were an equal sign, and this equation has a graph that's a line, where the y-intercept is -4 and the slope is +1. So here are a couple of ordered pairs that are on the line. And so now we're going to connect these dots with a solid line because the inequality at the beginning is less than or equal to, which means that the ordered pairs that are actually on the line are part of the solution set. So the line is solid and not dotted. Now to determine the region that solves the second inequality, again, let's choose the test point 0, 0 to see if it works in our second inequality. And when we plug in 0 for y and 0 for x, we get the inequality that says 0 is less than or equal to -4, and this is not true. So our test point does not work in the second inequality, which means that we're going to shade the region that does not contain 0, 0. And that's the region that is below the line. So now we want to find out where these two regions intersect or overlap. So the solution region here is going to be the region that is both under the line but also above the parabola, which means that we're looking at this region here. The line above is a solid line, and the parabola below is a dotted line. And so this shaded region is our solution. This is how we would express that answer using an online homework platform. The solution region contained a parabola, so I'm going to select this vertical parabola tool. And in this tool, we have two dots that are on the parabola, which means that one of them is going to be at the vertex point and the other one is somewhere else on the parabola. So when I come down to the Cartesian plane, I'm going to have my vertex point being at the ordered pair 0, -7, and then I'm going to select one other point on the parabola that was -1, -6. Now we did want this parabola to be a dotted line, so we're going to choose this dotted line tool, and that makes the parabola dotted. So we can toggle back and forth between solid and dotted with these two buttons. Then I'm going to intersect this graph with a line, and on this line tool we'll also need to select two ordered pairs that are on the line. So we select the tool, we say we had -4 as a y-intercept, and since the slope was +1, I can just grab another ordered pair anywhere on the line to anchor it into the correct position. The line was a solid line, so I want to keep it solid and not make it dotted. And then now I need to shade the solution region, so I'm going to select this shading tool. So selecting the shading tool, I now come in here and shade the region that is above the parabola and below the line. And this is how we would indicate the answer using this particular software.